Okay, now we will introduce you about the phasor diagram. So before you know how to analyze the phasor diagram, then this one is the phasor diagram. So we need to know what is phasor. So a phasor is actually a vector which it has a constant magnitude. So the magnitude here means that this length, okay, this length. This length at here represent the magnitude. So the constant magnitude, and it rotates with anti-clockwise. So means that for your phasor diagram is rotating in this direction. Okay, it will rotate in anti-clockwise direction with a constant velocity. So how can you generate a wavefront diagram based on the phasor diagram? So the first thing you need to do is you have to know where is the initial positions of your phasor. So whenever you want to analyze the phasor diagram, please refer to the initial positions. Means when your t equals 0, where is the positions of your phasor? So there are four types of wavefront here. So when t equals 0, this phasor is at these positions. So when it is at these positions, so means that it starts from 0, angle is equal to 0, and the phasor is equal to 0, so it will generate a sine graph. Okay, a sine graph. So it can be represented, let's say this phasor is a current. So you can be written as I equal to I naught sine omega t. So if this phasor is a current. Okay, let's say this one. So for the second phasor, which the initial position is start from here. So when t equals 0, the phasor start from here. So the current start from here. So it will generate a cosine graph. So you will have a cosine graph in this direction, cosine graph. So your phasor at here is actually your current. In this example is a current. So you will have this cosine graph and represent by this equation, means cosine equation. Okay. Next, the third phasor diagram, which when the t equals 0, it starts from these positions. So it is actually opposite to the first one. If you look at this is a sine graph. So the third one, which is opposite to the first one, so it will cause a negative sine wavefront. So you will have a negative sine graph. Okay, you will have a negative sine graph. Thus, this negative sine graph will have negative sine equation, which is I equal to negative I naught sine omega t. Okay, so for this one, it's opposite to the second one. So the second one is a cosine graph. So the fourth one will be a negative cosine graph. So you will generate a negative cosine graph, which can be represented as a negative I naught cos omega t. So you have to be very clear, because this phasor diagram will help you to simplify your vector. Okay, so let's say you have two phasor in one phasor diagrams. So for example, like you have phasor P and phasor Q in one phasor diagram. So you look at these two, both length of this P and Q are the same. They have the same radius. So means that the amplitude of both phasor are the same. So they have same amplitude or same maximum value. Okay, they have same maximum value. In other words, it have same amplitude. Okay, but for P, due to P start from here, so we will generate a sine graph. For Q, it will generate a negative cosine graph. So this one is rotating in anti-clockwise direction. So in other words, when t equals 0, so P will lead Q P will lead Q by pi per 2 radian or 90 degree. So you will look at this. This is leading Q with 90 degree. Yeah? So I repeat. When T is start from 0, P is at these positions, 0 positions. But Q is negative 90. So it will lead, P will lead Q by pi per 2 radian or 90 degree. In other words, we say Q lag P by pi per 2 radian or 90 degree. Okay, so if you want to write it in an equations, so for phasor P, because phasor P is a sine graph, it generates a sine wavefront, so you will have y equal to y naught sine omega t. Okay? Phasor Q will here have y equal to y naught. This is a negative cosine, so we will have negative cosine equation, negative y naught cos omega t. Okay? Well, if you look at this example, P and Q have different magnitude, have different length. So they are different magnitude. So Q is shorter, so it will have shorter amplitude. So if you look at this, so Q has a shorter amplitude compared to the P, compared to phasor P. So Q is less, smaller magnitude than P. But both generate a sine graph. So both have a sine graph, so they are not leading or lagging each other. They are in phase. So we call this P and Q in phase, because they start from the same initial position. Why? Because they start from same initial positions. But they are different magnitude. So P has a bigger magnitude than Q. So your graph will have this type of graph. Of course, if you written in equation, let's say your P, phasor P, so your equation will be sine graph. Okay, for P will be equal to yp sine omega t, because yp has a bigger amplitude. Then Q will be y equal to yq sine omega t. Okay, so this is the phasor diagram that you have to know. So in other words, you have to complete your exercise 18.2.